and welcome back to Merseyside, to the home of the Mk2a PV Power Router. This is a run through of the facilities of the latest version which I've put on, which is the revision 3 of the Mk2a. The Mk2a is a step up from the previous Mk2 version, which was posted about 6 months ago. Mk2a has all integer maths, and all of the general processing is hidden away in the ADC conversion periods, so it runs a lot faster than Mk2, and also the sampling is more even because it's running at the flat out rate of the ADC subprocessor in the Arduino, and the Arduino itself is idle for 40 or 50% of the time. So the Mk2a is much more suitable for anyone who wants to enhance the basic power diversion facility that I've put in for displaying or measuring other things. There's now more spare time available without affecting the underlying code and the ability to divert surplus power, which is the main interest that I have. So this is the code. Simply put it on the laptop, brought it down to the garage. I've put it through via tally mode, which is the integrated calibration feature, and a 60 watt light bulb looks like 60 watts, and a 750 watt space heater looks pretty much like 750 watts. So I've now commented that back out, so we're now running just in ordinary mode. I've got speed check in there. This is a means of demonstrating that we're not taking longer with our general processing than the ADC conversion periods allow. And Rev3 has an anti-flicker mode, so we have an operating state there, and we're currently in the normal state. I've simply put one extra line in. One line says normal, one line says anti-flicker, which gives me the opportunity to change it one-handed if I can hold the camera with the other side. So we're now running. We're on this prototype rig of mine, which is pretty basic but still works. It's got the triac, it's got the zero crossing detection trigger sitting down in there, and we're getting nothing out of our PV, which is on standby because it's 5 o'clock at night. We've got a standard CT here, and because we've got no real power, surplus power, I'm having to generate some PV power by simulated means, and I've got in addition, on the neutral wire coming in, I've got 2 loops of wire through which my actual load goes through. This current is going in the opposite direction to the primary, so the first loop cancels out the effect of the current coming in from the mains, and the second loop makes it look as though the current that's coming in is actually going out. So real consumption, for which I'm paying from the mains, looks like PV power to the CT and hence to our system. So we have power coming out of my mains there, going around a system here, coming up to this, and coming down to this heath rod arrangement down here, where we have 2 loads, one of which is a space heater, which I can put on as much as I want, 750 up to 2 kilowatts, and I also have this Bosch hot air blower, which has a 750 and a 1500 setting, so I can put any or all of those on to simulate PV power, and that will make the system think that we're getting some surplus, and will start my system flickering up here. So let's see if it works, see if I've set it all up. So the first thing I'm going to do is to put the space heater on. The other thing I've got, just while I think about it, this annoying light here is a 60 watt filament bulb, so that we can get some real effect as to what flicker is happening as we go through anti-flicker mode. So this is a real bulb sitting on a ring main. It's not on the same circuit as our dump load is, but it's on the same circuit as I'm simulating my PV from. So if I put on 2 kilowatts here, that should fill up the energy bucket pretty quickly. We're flashing away quite a lot, so 2 kilowatts is about 2/3 rate, so we'd expect that to be flicking at something like 2/3, but I do have a few hundred watts of base load in the house. So if I put that down to its lowest level, which is 750, then we'd expect the flicker to be quite slow. Now this is flicking just stop the camera from shaking, a few times a second. So I don't know, 4 or 5 times a second, something like that. It's a bit too fast to count. So that's what 750 watts of surplus power it's not surplus power, it's some surplus power. It's the difference between 750 watts which I'm generating or simulating to generate and what the house is actually consuming. Given that I've got the fluorescent lights on, there's a couple of fridges and so on, I think the computer's on standby, there's probably only 300 or 400 watts of genuine spare. Now at this stage, one interesting thing to do is the 750 watts that I'm generating is through a resistive heater. So if I just at the same time put on the 750 watts of my hot air blower, then it flashes more, which you'd expect. And then if I just put that down on the floor, somewhere where I'm not going to cause any damage, and switch off the space heater. Now this is flicking much the same, which is a 750 watt load replacing another 750 watt load, but the significance, as anyone who's been following these discussions, is that the half power load of my Bosch hot air blower is actually only a half wave load, so it's a 1500 watt element running at 50% duty cycle, and that seems to me to be flashing at much the same rate as if I put the other one on and then switch this one off. So the same effect is seen in both cases. In one case we have a 750 watt sine wave, in the other one we have a 1500 watt sine wave, or that's what the current looks like, of which only 50% is present. And the significance of this is that the way the filtering or the processing works for the current stream on Rev3 of the Mk2a is that I do no pre-processing whatsoever from the raw current samples. So the raw current samples are coming in based at 512, 511, something like that, wherever the resistive divider happens to be. So we are putting in a small sine wave based on 511 or something like that. And all that DC offset is being removed in the maths. So for the purpose of generating, of calculating real power, there really is, as you can see, no need to remove the DC offset. So that's 1500 watts. If I put on the Bosch that much more, that's now another 1500 watts. What I'm trying to do is to put on enough load so that everything is on. That's 2 kilowatts, that's 2.7, and that's now nominally 3.5. So I've got 3.5 kilowatts of simulated power, and it should be flashing. It should be on pretty well constantly. I don't know why it's flicking. Maybe I'm not quite overcoming my base load, but that's, as you can see, that's all working nicely in the normal mode, not in the anti-flicker mode. One of the benefits of this test is that I'm actually heating up my water while I'm doing this, so it's not all just heating up air. Now the next thing I would like to do is to go into anti-flicker mode. So if I could just hold the camera still here, we've got these 2 lines here, and so all I'm going to do is to comment out the one that's active at the moment and include the one that was commented out before. So we're now in anti-flicker mode as opposed to normal. Compile the code. Now I've still got speed check in there. I think I probably meant to comment it out, but it just means there'll be an extra LED flashing on board the Arduino, but never mind. So we're now working in anti-flicker mode, and on the Arduino we will have a little flick coming up once per few seconds. I think it's every 5 seconds. This is simply the transmit. Just checking, yep, that's the transmit LED. So what's happening there is every time there's a flick on there, we're getting a number coming up on the serial monitor. So if I just open the serial monitor, I'm very hopeful that we'll see zeros, and zeros means that we are within that 5-second period, never failing to This isn't showing very well, but they are all zeros. We're never failing to complete the general processing within the ADC conversion period. Okay, so if I now switch on my heater to 2 kilowatts as we did before, energy bucket fills up, this time to 80%, then drops down to 20% before it goes off. We have some hysteresis in now because we're in anti-flicker mode, so it's toggling between 80% and 20%, but when the bucket gets to 80%, if it's not 5 seconds since the load last went on, then it will stay on until it gets to 100% full, and at that stage there's a cap, so essentially the bucket overflows, and if that happens we see that on the onboard LED. So if I have a look on here, I think there's a pretty good chance that we're going to be seeing some significant flashes. So every 5 seconds the one on the right is coming on. I really should have got rid of that other one, I will do in a minute. So the little flick on the left every 5 seconds is putting out a value. The one on the right is coming on again every 5 seconds to show us that we're getting some overflow, and overflow equals lost benefit for anyone who's interested in diverting power, so ideally we'd want to do something about that. So at the moment I've got 2 kilowatts of simulated power, I've got 3 kilowatts of real dump load, and we are losing a portion of the free energy every 5 seconds. So this will be also running at 5-second period. So just before this comes on, that's when the LED, the onboard LED pin 13 will show that we're losing power. If I put this down to 750 rather than 2 kilowatts, what we'll now find is that it'll be off for much longer than it's on. When it goes on, it will stay on for just a couple of seconds, because that's all it will take to drop the energy bucket from its 80% to its 20%, and it'll take a sufficiently long time to build back up again so that the anti-flicker measure won't come in. I hope this is going to come in at some stage. Can go a long time otherwise. Sorry, I've turned the whole thing off. Let me put 2 kilowatts on to get the thing back up to speed, and now we've just got 750, so we should get a very slow flicker rate. There we are. It comes on for just a second or so while the energy bucket empties, gets up to 80%, but I think it's very likely that we won't be detecting any overflow here. I've got too many LEDs on the go. The green one is obviously the power, the one on the left flicks, there it was, and if there's no LED on the right flicking, which I don't think there is, I don't think we're getting any overflow now, but this is not the best of tests. Anyway, what I want to do now, I don't know if this is picking up, but every number on this screen I can assure you is 0, so we are never failing the speed check test. So I think what I'll do now is close this down, remove speed check by commenting out that line. We're still in anti-flicker. Now what I want to do is to go down a couple of screens to the line that says minimum time between activations, which was 5, and I'm going to change that to 3 and then recompile. So what we're now doing is we're saying for anti-flicker 3 seconds must elapse between the load being activated once from when it was last activated. So this is a much less stringent requirement than 5 seconds, and I think there's a very good chance that however much PV we simulate, we won't get overflow, or the amount of overflow will be very short. So I've simply compiled it. We're running away. I've obviously left something on. I've still got my 750 watts on. I've forgotten about that. And so this will be cycling at a rate which I'm confident is lower than 3 seconds, so we're not going to be seeing any overflow. But if I put a higher rate, which was, let's say, 2 kilowatts, so we're now going to 2 kilowatts, this will be on for much longer, and I think it's very likely that this cycle rate will be less than 3 seconds, in which case we'll see no yellow light coming on here. So because I've removed speed check, the left hand LED isn't coming on, and because I've reduced the minimum time between activations to only 3 seconds, it's taking just over 3 seconds for the bucket to charge up from 20% up to something less than 100% and back down to 20% again. I should have done the maths before doing this. It'll be 3 point something seconds with a 3 kilowatt load, so we are not overflowing, which is good. Now the only 1500 watt load I've got here is the Bosch, so if I switch this one off, we've now got no PV being generated. Needless to say, this is off. If I now put this on to 1500 watts, then this is half power, and this should now be cycling as fast as it will do. So endeavouring to point this lethal hot air gun somewhere that's not going to do any damage. We'll just peek down here, and we're not seeing the yellow LED coming on at all. So we are now getting 50% nominally. The dump load was on 50% of the time because I had a 1500 watt generated and 3 kilowatt load. That's off. Switch it back on again. So this is the latest version of the code, diverting power at the maximum flicker rate that it does, with a 3 second rule in there. So if I were to take anti-flicker mode off, it will be flashing away 10, 20 or 25 times a second. With the anti-flicker mode on, it's just flashing once every 3 and a bit seconds or something like that. So that's how anti-flicker mode works for real in the latest code. I hope I've covered all the things that are relevant. If anything isn't relevant, I've posted quite a few videos already with some of these things in a little bit more detail. Otherwise, please feel free to sign up to the forum, openenergymonitor.org forum, and drop a question there, and somebody will answer it. There's quite a few people who are very switched on to how all this works now, so it may well not be me. Somebody may jump in there first, but it's a good community for putting ideas like this around the place. And I certainly wouldn't have got to where I've got to today without a lot of help from the people on the forum. So thanks everyone for all your help. So I look forward to hearing some feedback or success stories as to how this code has been put into other people's build. And thanks for watching, and hope to speak to you on the forum.